Okay, section 4.5, inequalities involving quadratic functions. Now let's summarize what our steps are for solving quadratic inequalities and work a couple of examples. So what we found before in our exploration was that all we need is the direction of opening and the x-intercepts. But we also need to get our quadratic inequality in the correct form. So the first step is to rearrange the inequality so that 0 is on the right-hand side. So that's the first thing we'll do. Let's look at example 1 and go through the steps. So we do not have 0 on the right-hand side. I need to subtract 2x from both sides. And so for step 1, I have negative x squared minus 2x plus 8 greater than 0. Now I have it in the format I need. Determine direction of opening. What's the direction of opening for this quadratic? Well, a is negative, so it opens down. Step 3, solve ax squared plus bx plus c equals 0. Why are we doing that? Yes, that's how we get the x-intercepts. And remember my trick, I like to multiply by -1 if my coefficient of x squared is not positive. -1 both sides, and now I get x squared plus 2x minus 8 equals 0, and that factors nicely to x plus 4 times x minus 2. So x plus 4 equals 0, x equals -4, x minus 2 equals 0, x equals 2. All right, so we've gotten through step 3. Step 4 now says to divide the real number line into intervals using this. So we know what we're going to do. We don't need the whole graph, but it's helpful to know that on the x-axis where we're crossing, right? So we're going to cross at -4, and we're going to cross at 2, and we know it opens down, so I'm just making this little sketch. Because it doesn't matter how high it goes, we saw that doesn't matter. I don't need the y-axis, I don't need all that information. I don't need the y-intercept. Step 5 says to determine the sign of ax squared plus bx plus c in each interval. Remember, ax squared plus bx plus c, that is our f of x. This is our function. So in this interval, it's negative. In this interval, it's positive. And in this interval, it's negative. We'll have 3 intervals because we've divided it with these 2 points, the x-intercepts. So that's step 5. And then step 6 says, determine your solution set. So we're solving a greater than. So it says the solution is the intervals for which the function is positive, greater than 0. So here it is. And I don't want or equal to, so I can't use the -4. It has to be open there. So there is my interval from -4 to 2, not including those 2 points. My y values are all positive, greater than 0. Okay, let's go through those steps one more time on this one. Step 1 says to get it in the format we want with 0 on the right-hand side. Well, that's already done, so I'm just going to rewrite it, but it has already been done. Step 2 says to determine the direction of opening. A is +1, so it opens up. Step 3 says to find the x-intercepts. Solve ax squared plus bx plus c equals 0. This is a nice factorable trinomial. So we have what, +7 and -4. So x equals -7 and x equals +4. Now we're to use those numbers to break up the number line. So here's our x-axis. You've got to put them in order, the lower one on the left. And just a little sketch of our parabola so I can see easily to label the positive intervals and the negative interval, you see? So now I can answer the question. So that's labeling the intervals 5. And step 6, determine your solution set. We're looking for greater than or equal to, which, you know, we're looking for positive or include those endpoints. So we are, the answer, our y values are all positive, starting out here at -infinity until we get to -7. And we do want to include values that give us a 0 for y. So that would be that -7. And then again, we have positive values, union, starting at 4, positive or 0, greater than or equal to 0 at 4, and all the way to positive infinity. Okay, so all we need are the x-intercepts and the direction of opening, and we can tell what intervals give us either positive or negative, or greater than or equal to, or less than or equal to results.